Now that we know what a separable equation is, let's talk about how to solve it. Hint, we're going to separate the separable equation. That's what we do. Okay, so we'll start with an example. I'll just solve this differential equation. dy dt equals t divided by y squared. And again, this is a separable differential equation. It's just t times 1 over y squared. Some function only of t times some function only of y. This is separable. So we're going to solve it by separating. Okay, let's move the y's over to one side and then the t's over to the other side. So let's see, to do that, we're going to have to multiply both sides by y squared. When we do that, we're going to get y squared times dy dt equals t. And now what we can do is we can really integrate both sides. Now, the long way of doing this is to set up an integral here and do a substitution on the left-hand side using the chain rule. But usually what people do is it's really like a lazy shorthand, is they multiply both sides by dt. Now this is not technically how derivatives work or how calculus work, but it does work here. Again, really what we're doing is a substitution. I can talk more about that here, but we're not really going to go into the details. So when we do that, we're going to get y squared dy equals t dt. We'll take the integral of both sides. And we know how to find both of these integrals. No problem. Not pretty easy. Just use the power rule. 1/3 y cubed plus a constant and 1/2 t squared plus some other constant. We don't know what the constants are, but again, remember, it doesn't really matter. A constant minus a constant, still a constant. It's just a different constant. And now we're curious what y is. Remember, we want to know what function makes this true. So we're solving for y. All right, what did we do first? We separated. And then we integrated. And now we're going to solve for y. So to do that, right, we'll subtract a constant, we'll get a new constant, multiply everything by 3. You all know how to solve this equation. Right, multiplying things by 3, and again, some constant multiplied by 3 is really some new constant. Okay? I skipped C3, I skipped C1. We can call the constants whatever we want. Now just take the cubed root of both sides. We don't need a plus or minus, that's only when it's an even exponent. Get 3/2 t plus some constant, okay? And yeah, that's our solution. You want to know whether you're right? Check it. Take the derivative of this. Is the derivative of this equal to t over the function squared? Find out. We're not going to do that on this video though. But yeah, that's it. All right. This whole video. Whole method. All right, you can move on to the next video, but I'm gonna check the answer, okay? Not that I've never made a mistake, not that I've ever made a mistake in my life. Yeah, the video's over. But we can check, right? What is the derivative with respect to t? Well, this is 1/3 exponent, so we're gonna use the chain rule. So it's 1/3 times the inside, which stays the same. Subtract an exponent times the derivative of the inside, which is just going to be 3t. The 3's cancel, and we're left with t divided by all of this stuff to the 2/3 power. And the right-hand side is t divided by, oh, it's just all this stuff to the 2/3 power. Yep, it checks out. Cool. And that's how you check your answer. The end.